Welcome back to the advanced Arduino basic project, and today we will learning about temperature controlled fan using closed loops concept. And here is the agenda: overview, components, principle and procedure. In this lesson we will program the Arduino to achieve the automation of a temperature controlled fan system. The system will automatically control the fan speed using a temperature sensor based on the surrounding temperature. The required components are Arduino Uno, temperature sensor, DC motor, NPN transistor, breadboard and connecting wires. The system works on the principle of a closed loop control system. The closed loop control system, in which the output is continuously monitored and fed back to the controller so that the system can automatically adjust its operation. So in this project we using temperature sensor that will continuously measures the surrounding or room temperature. The sensor converts this temperature into an electrical signal and sends it to the Arduino. The Arduino reads this temperature value and decides how fast the fan should rotate. The Arduino controls the fan speed using pulse width modulation signals. If the temperature changes again, the sensor sends the new temperature value to the Arduino, and the Arduino adjusts the fan speed again. So the system is continuously checking the temperature and automatically correcting the fan speed. So because the output condition means temperature is continuously monitored and used as a feedback, the system works as a closed loop control system. So in closed loop system, it uses the feedback from the output and it is automatically adjust itself, and it is more accurate and efficient. For example of closed loop system is temperature controlled fan, air conditioner thermostat. So in air conditioner thermostat, it measures room temperature and adjusts cooling automatically, and also automatic water tank controller. So in that it checks the water level and turn the motor on or off. But in the closed open loop system there is no feedback. The system works with fixed input and does not adjust automatically, and it is less accurate. For example, a normal fan running at a fixed speed regardless of temperature. So speed doesn't change based on room temperature. And washing machine timer, so it runs for a fixed time regardless of how clean the clothes are. And next is the procedure. First we need to build the circuit. Here we using DC motor, this is temperature sensor, and this is the BJT NPN. So this is the Arduino, this is the control center. So it provides power to the components, and this is temperature sensor. So this Vout is connected to the analog pin, so it sends varying voltage to the Arduino. And this is NPN transistor. Since the Arduino pins cannot provide enough current to spin the motor directly, so this acts as an electronic switch. So this base pin is connected to the pin number 3. So it tells the transistor to, so here Arduino tells the transistor to turn on, and this is collector and this is the emitter, and this is DC motor. So when the transistor is on, it completes the circuit to ground and the fan spins. And next is the program. So this is pin declaration. So here we connected temperature sensor to the analog input and motor pin to PWM enabled digital pin used to control the fan speed. So this one. And next is the setup function. So the serial begin, it initializes the serial communication values in the serial monitor, and this configures the motor pin as a output. So the Arduino can send PWM signals to control the fan. And here we having speed decider. So this is a function determines the appropriate motor speed based on the temperature. If temperature is below 20 degrees Celsius, then it will return 0. So meaning the fan is off. And if it is above 40 degrees Celsius, then it is returns 255, means it is the maximum duty cycle. PWM duty cycle means it is full speed. If temperature is between 20 degrees Celsius and 40 degrees Celsius, it returns one math function. So this function linearly converts the temperature range, means 20 degree to 40 degrees Celsius into PWM range, that is 0 to 255, enabling gradual speed variation. Next we using the loop function. So this runs continuously, but setup function runs only once. When the Arduino starts, it will runs. So in the loop function, here you can see analog read of temperature, means it reads the analog voltage from the temperature sensor, and this map function converts the raw sensor value into an actual temperature range, means minus 40 degrees Celsius to plus 125 degrees Celsius, and the speed decider of temperature calculates the required motor speed based on the temperature, and the serial print line display the calculated PWM value in the serial monitor, that is for observation. And analog write motor speed decider of motor, then speed decider of temperature. So it sends the PWM signal to the motor driver, thereby adjusting the fan speed automatically. In step 3, compile the program and upload to the Arduino board. Let's do this circuit using Tinkercad simulator. Login, create, then circuits. The required components are Arduino Uno, temperature sensor, motor, and NPN transistor. So this NPN transistor allows the low power signal from the controller to switch the high power fan circuit. So motor, NPN transistor, then temperature sensor, then one breadboard, then Arduino. So these are the required components. Now we need to wiring. So this is connected to the motor terminal. So and this is connected to negative rail of the breadboard. So this is the ground. So I'll use black color, and it should be connected to the BJT collector. This is the collector pin of the BJT, and base is connected to the Arduino pin number 3. So here pin number 3 should be connected to the this one, and this is, I will change the color, and this should be connected to the positive rail. I'll change the color as red. Motor connection is over, this connection is over, and this Vout should be connected to the analog A0. So this one. So and this power pin should be connected to the positive rail of the circuit. So this is positive rail. So yeah, I will change the color as yellow. Now this is done. Now we need to write the code. Here you need to select text. Before that you need to short this 5 volt because I am connecting 5 volt here, so you need to short this one with this. So change the color as red, sorry, not black, red. Then ground connection. So here ground, take this and connect it to the negative rail, and this is negative rail. Now we need to write the code. So here first we need to do the pin declaration. So hash define temperature A0. Then we need to define the motor value. So motor is connected to pin number 3. So in the setup function we need to write the serial dot begin of 9600. Then we need to write motor as a output. Then we need to write about the speed decider. So int speed decider of int 10, then open flare bracket. If temperature is below 20 degrees Celsius, then it return 0, semicolon. Then if temperature is, else if temperature is above 40, then it should return 255, means that is full speed. In else condition means temperature is in between these two, it return map function. So temp, 20, 40, 0, 255. Yeah, in this, then close the bracket. Then we need to write the loop function. So here int temperature equals to analog read of this value temperature, then semicolon. So then temperature equals to map of temperature, comma 20, comma 358, comma minus 40, comma 125, followed by semicolon. Then serial dot print of this speed decider of temperature. Then analog write of motor, comma speed decider, sorry, it should be small letter, speed decider of temperature. So coding part is done. Now start simulation and check any errors. Yeah, invalid processing define, it should be define. Now run. So here you can see this is rotating and observe the value. Now we need to change the value of temperature. See 0 rpm. Now vary, this motor is rotating, you just observe the value also. Yeah, now see 0. Now you can see motor is rotating. So this is 178. Yeah, vary this. Yeah, now full speed it is. Yeah, now you can see. So this is about the temperature controlled fan. That's all about the temperature controlled fan. For more project, please watch the upcoming videos. Thank you all.